Hi, my name is Dr. Eyal Weiss. I'm the founder and CTO of Cybord. We do electronic components analytics. I came to this subject after I was developing a new technology for 12 years for a military project, only to fail in the field after a few months because of the counterfeit component. This was a $1 billion project that was almost cancelled because of a 3-cent capacitor. Why do good projects fail? In 8 out of 10 times, it's actually the cause of the failure is the component itself, not the process, not the design, but actually faults in the components. When I'm talking about unsafe components, they may be either recycled components, clone, fakes, forged, aged, and so forth. They may be caused by errors or bad handling, leading to defects or oxidized leads. Our solution is actually very simple. We look at the components. Everything that you need to know about a component, from is it safe to use or not, can be found from the exterior of the component, from its visual aspect. If it's a recycled component, this is going to be evident it was removed and replaced. If it's a fake, it means that someone else packaged it. And if you have a fine enough algorithm that can make the difference between different manufacturers of the same components, you can detect it based only on the visual inspection. So what is our solution? We are using the images taken by the pick and place machine during the assembly. The images are taken anyway for alignment of the component onto the board. We take those images and we upload to the cloud where we do the analysis. I will soon explain what we do. We are already compatible with most of the largest manufacturers of equipment. Another way to get the images is by a reel-to-reel inspection machine. In this way, we can scan reels even before they are accepted to storage, and we can qualify all of them. The idea is to qualify or check every component that is placed on every board. So we're using AI and big data analytics to test every one of the components, these 6 tests. First, we identify the part. Is it the right part or is it the wrong part? Second, we look for homogeneity issues. Does this component look like the one before that and the one before that and so on? We identify the manufacturer, meaning is this capacitor, for example, come from Rata or from Samsung, because they look a little bit different. Then we can verify the age based on the condition of the soldering leads. We're looking for defects, and we can look for evidence of programming of the component, because if you want to attack through a component, you have to reprogram the component. Now, this is the micro level. We are using all this information to give value to our customers throughout the life cycle of the product, through pre-inspection, preventing bad components from getting on the boards, analyzing the quality of components and boards, and allowing traceability later on in the life of the project. These are all the tools that we use. We can give production analytics, and we can use all this information to track this every component placed on every board based on its visual features. So this allows surgical traceability. We are working with some of the largest companies by now. Our income is already by this year is exceeding 600K, and we are partners with Flex, Siemens, and with ASM. And our database already includes more than 700 million components. Our business model is SaaS. We charge per board that we inspected. Our go-to-market strategy is quite unique. We solve the pain to an OEM, which is our customer. Now, this OEM is manufacturing in many locations. So we are serving him on all of his locations. Now, let's take a look, for example, at one location, for example, Flex. Flex is also manufacturing for other OEMs. So by connecting to Flex, we can get to all their OEMs and then expand through Flex, for example, to their other locations. The TAM is very simple. We charge an average of 75 cents per board. There are 20 billion boards produced per year, so the TAM is about $50 billion. This is our patent portfolio, and this is our team. Thank you for hearing me. I hope you enjoy the rest of the presentation.